Hello, everybody. I hope everybody is doing fine. So, this is me, and I again welcome you in this lecture. So, in the previous lecture, what we have seen, we have learned some very important concept related to this chapter. Now, in this particular part, we will study about the image formation. What will we study? We will study about the image formation by the concave mirror. By the concave mirror. Okay. So let's move on to the next slide. Okay. So in this slide, I will be giving you a quick recap what we have seen in the previous lectures. So in the previous lectures, I told you about the spherical mirrors, and then we saw the types of spherical mirrors, concave and convex mirrors, concave and convex mirror. And we had also seen some rules to form a image, form a image. So to have a clear understanding of these rules is very important, because without it we cannot proceed, because we will be forming images of the objects. So to form the images, we need to have a clear idea about the rules of image formation. So here, let me give you again a basic idea how an image is formed. So let's suppose this is a spherical mirror. Okay, this is a line, and this line we call principal axis. Let me write it here. PA. It means principal axis. So this is a line coming from this side, and after the reflection, it goes back in this direction. And this point is known as F. So what is this rule? This rule says that if a line coming parallel to the principal axis, then after the reflection, it passes through the point F, or we can say that it passes our focus. Now, let's talk about the second rule. So, according to this rule, what happens? This rule is just reverse of rule number first. According to this rule, if a line if a line passes this focus F, for an example, this is our point F, and if a line passes this focus F, then this will become parallel to the principal axis. So this is a principal axis, this is a incident ray, and after the reflection, it is going like this. I hope you got my point. Now what is the third rule? This is rule number third. And according to this rule, what happens whenever a line passes the center of curvature, then it also goes back through the center of curvature. If a line passes through the center of curvature, then after the reflection, it will also go back passing through the center of curvature. I hope you got this point. And in the previous lecture, I had explained this term very explicitly. I had also given you the logic, like why this line after the reflection goes passing through the center. I also gave you the logic. Now, let's see rule number 4. So what happens? According to this rule, whenever a line, let's suppose this is our concave mirror and this is a line, whenever this line strikes at point P, then it goes back obliquely. it goes back obliquely and the angle is same. This is angle of incidence I and this is angle of reflection R. Now I will always be the same because we have seen the rules for reflection, the laws of reflection. So according to the laws of reflection, we know that I, it means angle of incidence, is always equal to the angle of reflection. Okay, so I hope you understood these four rules to form a image. Okay, now let's move to the next slide and let's try to understand formation of images by a concave mirror. So this is very important. This will be asked very frequently in your examination. Okay, so we will see how a image is formed by a concave mirror. So for your understanding, I put an image here. So you can see this is the image, this is our concave mirror. Now, why this is a concave mirror? Let me give you again an idea about it. Why it is a concave mirror? Because here the light is reflected through the inner part of this mirror. This is our mirror. This is outer part where we have done coating, and this is inner part. This is our inner part, and from this part the light is being reflected. Okay, so this is a concave mirror. Now let's suppose here at this point we have put an object. Okay, so what is the distance of this object through this mirror? So let's see, let's suppose the distance is infinite. The distance here is infinite. Now you might be surprising, so how can here the distance is infinite? Because here the object has been kept far away from this mirror. That's why we can say that the distance between this mirror to this object is infinite. Okay, so let's suppose this is our object, a ray coming from this direction, coming from this point A and going like this, going parallel to this principal axis. This is again, let me write it for you. This is our principal axis and this is our ray and it is going parallel to this principal axis, and after the reflection it is passing through the point F, or we can say it is passing through F. Okay, now let's see, this is another ray. It is also going parallel to this principal axis. Okay, and after the reflection it is also passing the point F like this. So now these rays are meeting at this point F, and I told you that where the reflected rays meet, let me write it here, where the reflected rays meet, image is formed at that point. So here, what is that point? That point is F, where these reflected rays are meeting. So we can say that the image is formed at point F. Okay. So here I have also written the form at F. It means the image is formed at F. Now let's talk about the size of this image. So as you can see here, the size is very small. The size is very small, or you can say this is point size. You can just draw or dot a point like this. Image is point size. Now, for the very small images, we use a term, and that is diminished. And that is diminished. For the very small images, we use a term or we refer those images by this term diminished. Diminished means very small. Let me write it here for you. Diminished means very, very small. Now, in this case, this image is very, very diminished, or we can say it highly diminished. Highly diminished. As I have written here, highly diminished. Now, after commenting on the size of the image and the location of the image, let's talk about the type of the image. Let's talk about the type of the image. Let me write it here for you. Type. So in the previous lectures, we know that there are two types of images. First one is virtual image. Virtual image. And the second one is real image. So now, if I ask you that what type of image it is, now it is a question for you. What is the type of this image? So I hope you answer this question because your concepts are very clear. Because in the previous lecture, I told you that if the rays are actually meeting at the point, then the image is formed as real image. Okay, so and in this case also, the images are meeting at this point. Actually, these are real images. Okay, because the rays are real here. So that's why the type of the image is real. So this is a real image. And remember a very, very important point. I am making a star here. This is very, very important. Now, what is the important point? So, the real images are always inverted. Are always inverted. Now, what is inverted mean? So, when I explain a plane mirror, I told you that there are two types of images. First one is inverted and the second one is erect. Second word is erect. So erect images are the upright images and inverted images are the opposite images, or you can say inverted images. So here in this case, because this is a real image, that's why it will automatically become inverted. Okay. So I hope guys you got my point. I hope you understood this slide completely. Okay. Let me give you again a quick review what we have seen here. Here we wanted to know that if a object is placed at infinite distance from a mirror, then what would be its position and what type of image will be formed. So here by this ray diagram, you can have a clear idea that here we have made two rays. First one is this ray which is going parallel to this principal axis, and after the reflection it is passing through point F, and here there is another ray going parallel to this principal axis. After the reflection it is also passing through the point F, and these rays are meeting at point F. So the position of the images is at F. It means the image will form at point F or focus. This is focus. Okay. Now, we also learned that the size of the images in this case is very, very small, or we can say it is a point size image. You can see this is a point size image. And the third point, we have seen that in this case the image is real because here the rays are actually meeting. That's why in this case the image is real. And we have also seen that the real images are always inverted. So that is why here in this case, the image will also be inverted. So I hope guys you got me. Now let's move on to the next slide and let's try to understand what is there for us. Okay, so here we are. We have come on the second slide and here we will place this object ahead of the infinite. Okay, in the previous case, we have placed object here at this point, infinite. But now in this case, we have placed our object a little bit close to the this point C. Okay, beyond, or we can say beyond C. Okay, for this position, what term we use? We can say this here we have placed the object at beyond C. Okay, now in this case, let's understand what is the position of the object. So by this diagram, you can clearly see that this is a ray coming parallel to the principal axis, like this. And after the reflection, it is passing through the point F, like this. Okay. Now, this is the another ray which is passing through the point C. Now, this is again a question for you guys that if a ray passing through the point C, then after the reflection, where it goes. So your time is up now. Now it's my turn to answer. So here, as we have seen, the fourth rule of image formation that whenever a ray passing through the center, whenever a ray passing through the center, then after the reflection, it also follows the same path. It again goes back like this. So if it is coming like this, passing through the center, then it will also go passing through the center. So here in this case, the second ray is passing through the center, then it will also go back crossing the center. It will follow again its path. Okay. Now, if I talk about this ray, okay, then according to this ray, we have seen the first rule of image formation. Okay, and what happened according to this rule? Let's suppose this is your concave mirror. This is a ray coming like this, coming parallel to this principal axis. So, what will happen after the deflection? It is passing through the point F. So, the same thing is happening here. This is a ray coming parallel to this principal axis, and after the reflection, it will pass through the point F, like this. Now, what I told you that the image is formed where the rays meet. Okay, like this here. I have also written on the previous slide that where the reflected rays meet, image is formed at that point. So here, at this point, the reflected rays are meeting. So the image is formed at this point. Okay. So now, by looking at this point, what you can say about the position of the image? So here, the image is formed between this point C and between this point F. Okay, so here in this case, the image is formed between F and C, or you can say between the center, because this is center and this is focus. So the image is formed between the center and the focus. Now, if I talk about the size of the image, then here in this picture, you can clearly see that the size of the image is small. Size of the image is small. And what term we use for small is diminished. As I told you, for diminished means small, or you can say for small, we can simply write it diminished. So here in this case, the image is diminished. As you can compare the size of the images. This is our object. This is our object. This is our image. The image is smaller than the object. Now, after commenting on these two things, let's talk about the type of the image. Let's talk about the type of the image. So guys, now you tell me that what type of image it is. So you can clearly say that here the image is real. Now why this image is real? Because the rays are actually meeting. Right. The rays are actually meeting. That is the reason that here the image is formed a real image. Now if I talk about the type again, is it inverted or erect? Then you can clearly see that here in this case, this image is inverted. And there is another fact also I had told you that real images are always inverted. Okay, let me show you. Here I have written that real images. I had also made it a star that real images are always inverted. So this is also a real image. That's why it is inverted. So I hope guys you got it. Let me again give you a quick recap what we have seen. We are actually going to know that if I place an object before the sea, then what will happen? Or you can say if I place an object beyond the sea, then what is happening? That let's suppose this is a ray coming parallel to this principal axis. After the reflection, it will pass to this point F, and this is again a ray which is passing through this point C. After the reflection, it also goes back or it also follows its path. So that's why it will go passing through this uh, point C, or you can say center of curvature. So, and this is the point where rays after the reflection meeting at this point. So the image is formed at this point, and where it is point, this point is between C and F. So our image is formed between C and F. Now let's talk about the size of the image. So here you can see the image is smaller than this object. So the size of this image is diminished or small. What we write? We write diminished. Now what we have seen about the type of image, here the type of image is real because the rays are actually meeting and real images are always inverted. So till now we have seen two types of images, or you can say two cases of images. Now let's move on to the next slide. Let's try to understand the third case. Okay, so in this image, what I have done, I have placed this object at point C. At point C. So you should understand that what we are doing, we are actually placing this object coming to close to the mirror, because in this first case we had placed the image, the object at infinite distance, and in the second case, let me take you to the second slide. Okay, so in the second case we had placed the object a little bit closer to the point C. Now in the third case, what we have done, we have put the object at the point C. Now let's try to understand what happens here. So this is our ray going parallel to the principal axis, and after the reflection, it crosses the point F like this because this is our rule. Now this is again a ray which is passing through the F. It is passing through the F, and after the reflection, it becomes parallel to the principal axis. Now this is the point where rays after the reflection are meeting. This is the point where rays after the reflection are meeting. So we would say that here the image is formed. Okay. So now let's again talk about the terms what we have discussed in the previous two cases. The same things we need to discuss for this case as well. So our first thing what we want to know is the position of the image. So here you can see that the image is formed at point C. The image is formed at point C. Okay, so this is the position of the image. Position of the image. Now let's talk about the size. So here the size is same. The size is same of the object. Let's assume the size of the object is h, then the size of the image will also be h. So it means size is same. Size is same. Okay. Now let's talk about third point. So what type of image it is? So this is a real image because here also the rays are actually meeting. And you also know that if an image is real, then it is also inverted. So this is our inverted image. I hope guys you got my point and you understood this third case of the image formation. Now let's move on to the next slide and let's try to understand case number 4. So this is our fourth case. Okay. Now, as I already told that what we are actually doing in case number first, what we have done, we had placed the object at infinite. Okay. And in the second case, we took it a little bit closer and put it here. Put the object at this point, a little bit close to this point C. You can say beyond C. Beyond C. Now, in third case, what we have done, we have put the object at point C. We have placed the object at point C. Okay, and we took it a little bit closer. Now, in this point, what we will do, we will bring it a little bit more closer to the concave mirror. So we will place it between this point F. Let's suppose this is point F. So we will place this object here a little bit closer to the concave mirror. So we took it a little bit closer. Now let's again try to understand the ray diagram of this case. Okay, so you should know that this is our ray diagram. What it is, whatever we have been studying since a long in this lecture, this is a ray diagram. Ray diagram of concave mirror. Ray diagram of concave mirror. Okay. Now guys, this is our object. Now a ray is going like this and it is passing through the center. It is passing through the center. Now this is another ray which is going parallel to this principal axis. And after the deflection, it is passing through this point F. It is passing through this point F. And they are appearing at this point. They are appearing at this point. Let's suppose, let's give it a name X. X. So they are meeting at this point. So here, if you are asked that what is the position of the image, what is the position of the image in this case? So here in this case, the position of image is beyond C. Okay, because the image is formed beyond C. So that's why the position of the image you can say is beyond C. Okay, I hope you got it. Now let's talk about the size of the image. So guys, you can clearly see in this image that this is an object. This is an object. This is an image. This is an image. The image is larger than the object. The image is larger than the object. In this case, the object is smaller, but the image is larger. So that's why for the larger images, we use a term magnified. So if you are asked the size of the image, then you will say it is magnified. Magnified. Okay? I hope you got it. Now guys, let's again talk about the type of the image. Then it is again very simple. Here, the image is real and inverted because the rays are actually meeting. I think I should not explain you this again because I have explained lots of times, and I think now you remember this point and you will not forget it forever in your life, that where rays are actually meeting, then the image is always real. And real images are always important. So now I have a question for you. If real images, if real images are always inverted, then virtual images are what? If real images are inverted, are always inverted, this is 100% true. Then what about virtual images? So virtual images is just opposite to the inverted. And what is the opposite of inverted? Erect. Erect means upright. So here all the virtual images are always upright. Upright like this. Like in the case of what? Plane mirror. Very good. Plane mirror. When we were discussing plane mirror, we had seen that the images were used to be what? Upright. So that's why virtual images are always erect. So I hope you completely understood this case number 4. Let's move on to the next slide and let's try to understand case number 5. Case number 5. Okay. So here we are. This is our case number 5. Formation of images. We were discussing by the concave mirror, and this is our case number 5. So yet what we have seen four positions of the object. So at first position, we kept the object at infinite. Second position, we placed the object at beyond C, beyond C. And in third case, what we have done, we have placed the object at C. And in fourth case, what we have done, we have placed the object between C and F. Now what we are doing in case fifth, what are we doing? We are placing the object at point F like this. So in this case, what will happen? Let's suppose this is a ray. Okay, and this ray is going like this. And after the reflection, it is passing this point C. Now this is another ray which is going parallel to the principal axis, and the rays which are parallel to the principal axis always passes through the point F. So this will pass this point F. Now these rays will be appearing to be meeting at point infinite. They will meet at infinity. We don't know where they will meet, but they will meet at infinity. It means 4 from this, 4 away from this concave mirror. So the objects or the images or the things which are far away from the mirror, we say that those objects are at infinite. The image will form at infinite. Okay. So if you are asked what is the position in this case, so at infinite. Now let's talk about the size. So here the image size will be very very large as compared to the object. So we can say that in this case the image is highly magnified. The image is highly magnified. Now let's talk about the type. Then the type of this image is real. The real image will be formed in this case. And real images are always inverted. I hope you got my point. What I explained you, let me give you again a quick review. Let's see, this is a point F. We had placed an object here, and this is a ray going like this, and this will again pass through this center. This is again a ray which is going parallel to this principal axis. After the reflection, it is passing through this point F, and they will meet at point infinity. So that's why we can say that the image is formed at infinity, and the image is highly magnified, and the image is real and inverted. Okay, guys. So I hope you got my point. Now let's talk about the last case. You might be thinking that there are lots of cases, but I can definitely tell you that if you understand the logic behind it, then this is no more difficult for you. Because we are not doing something rocket science. What we are just doing, we are just placing the objects closer to the concave mirror. And if you have a clear idea about the ray diagram, then you can simply draw a ray diagram and you can simply locate the position of the image. It is very easier to. Now let's move on to the next slide. Let's try to understand the case number 6. So here in this case, in the previous case, what we have done, we had placed the object at point F. Now in this case, we will place the object more closer to this concave mirror, and we had placed it between F and this pole P. What is this? This is pole. I explained this to you in the previous slide, the previous part. I told you what is pole. So we had placed the object between F and P. Now what will happen? This is a ray, and this ray is going like this, and after the reflection, it will pass through the center. It will pass through the center. Now this is another ray which is striking at point P and going like this, going like this. So guys, as we know that whenever a ray coming obliquely is hitting this point P, it also goes obliquely like this. And this angle and this angle is always same because this is angle of incidence and this is angle of reflection. This is angle of incidence and this is angle of reflection. Okay, and the angle of reflection is always same to the angle of incidence. So the point is this ray is going in this direction like this, and this ray is going in this direction. So now tell me, do you think that these ray will these ray can meet at a point? I think your answer is no, because they are in different direction. This is going like this, one ray is going like this. If you keep moving it And if you keep moving this ray also, then will they appear to meet at any point? No, they are not going to meet at any point. So what you do, you can do one thing. You can move this ray in the behind the mirror, in the opposite direction. And you can also move this ray in the opposite direction. So if you move these rays like this, then definitely you will get a point where these ray appears to be meeting. So what we are doing here, we are actually increasing or moving this ray behind the mirror like this in the opposite direction. And here we got a point where these rays are appearing to be meeting. Okay. And attention, they are not actually meeting, they are appearing to be meeting. You have to be more precise here. You have to be more, attentive here. That the rays are not actually meeting, they are appearing to be meeting. Now, guys, if I talk about here that where the image is formed, then you can clearly see the image is formed behind the mirror. Behind the mirror. Okay, behind the mirror. So this is a position of image. Position of the image. Now, if I ask you what is the size of the image, then definitely you can see the object here is smaller than the image. The image is very, very large. So for the term which are very, very large, we use magnified. Magnified. Magnified refers the things which are larger. Now let's talk about the type of the image. Then you can say, then here the type of the image is virtual because rays are not actually meeting, they are appearing to be meeting. And virtual images are always what? Are always erect. So virtual images are always erect, and in this case the image is magnified and formed behind the mirror. So guys, this is the last case, and I hope I have been able to make you understand what are these cases and how the image is formed in these cases. Normally, students face difficulties while understanding these ray diagrams, but I hope I made it explicit for you. Now let's move on to the next slide and let's try to understand whatever we have seen in these slides in these six cases. I just put a effort to make you more easier to you to make it more easier so that you can remember it for your exams. So this is a first case where we have put the object at infinite. So the image is formed at the focus, and if I talk about the size, then it is highly diminished at point size. And if I talk about the nature of the image, then the nature of the image is real and inverted. The image was real and inverted. This is the second case where I had kept the object beyond the sea, or you can say a little bit closer to the concave mirror as compared to the previous case or first case. So, and in this case, the image is formed between F and C. And if I talk about the size is diminished. Diminished, we refer the terms which are small and we simply write diminished for those terms. Now, what about the nature? The nature is real and inverted. Now, we have seen case number third, and that is at C. It means we had placed the object at C. Now the position of the image was also at C. The image was formed at C, and the image was same size of the object. The object size and the image size was also same, and the image was real and inverted. The image was real and inverted. Now let's talk about the position of the object. And in the fourth case, what we have done, we had brought it more closer to the concave mirror. So we had placed the object between C and F. Now the image was formed at point C, or sorry, not at point C, beyond C. And if I talk about the image size, then the image was enlarged and real and inverted. Now, at case fifth, what we have done, we have kept the object at point F and the image is formed at infinity. Okay, you need to see it. You need to be, more attentive here. When we place an object at F, the image was formed at infinity. But when we keep the object at infinity, then the image was formed at F. Okay, so this is very important. You should remember these two cases. These cases are asked very frequently. So here image in this case was highly enlarged and real and inverted. Now let's talk about the last case, what we have seen in the last case. When we kept the object between P and F, then the image was behind the mirror and size of the image was enlarged and virtual and erect. This is the only case. This is the only case where the nature of the image is virtual and erect. The only case where the nature of the image is virtual and erect. So you should remember this point. Now, after understanding these things, let's go and move on to the next slide. So, yet we have seen the six cases of image formation by concave mirror. Now, we will try to understand what are the uses of concave mirrors. It is very, very, very important. Uses of concave mirror. Okay. So, guys, let's go to the next slide, the previous slide, and you can see that in these cases, in these three cases, you can see the image is formed in large. In large means the image is very large if you compare it to the object. This is, let's suppose, your object. This is, let's suppose, your image. So image is magnified in these cases. Okay. So my point to tell you this is that you can use this property of concave mirror in different fields. It has various applications because wherever you need to see an object, whenever you need to see an object, or you can say, let's suppose this is our mirror, okay, and this is you, okay, standing in front of a mirror, and you want your image to be magnified as compared to your actual size, then you can use this concave mirror. So concave mirror is used in the shaving mirrors because whenever we shave ourselves, then we need to see a image, or you can say we need to see a magnified image. So that's why concave mirror is used in shaving mirrors. Now torches also, okay, because whenever we need to reflect a light, then we can use concave mirror. Now searchlights, okay. Now why do we use it in searchlights? Because concave mirror has a property. Let me tell you what is this property I am talking about. Let's suppose this is your concave mirror, and let's suppose this is your object. This is a ray coming like this. Then it will pass through the center F. And let's suppose this is another ray coming like this, and it will also pass through the center F. So it is actually converging the rays. It is converging the rays. This action is known as converging action. Okay, and this phenomena, or you can say this property of concave mirror, is used in torches and searchlights and vehicle headlights where we have focus light. we have where we have to focus light, then we can use this property of concave mirror. But on the other hand, if I talk about the very convex mirror, then what happens in the case of convex mirror? It diverges light like this. It is not it is not actually converging light, it is diverging light like this. Okay, so this action is known as diverging action. Diverging action. Okay, so we had discussed about the concave mirror and we saw that concave mirror is a converging mirror. The other name of concave mirror is converging mirror also. Converging mirror. Okay, concave mirror is converging mirror. So if a question comes in your examination, then what is converging mirror? Then you should know that converging mirror is a concave mirror. Now guys, these are the uses of concave mirror. Let's move on to the next slide and let's try to understand what are some other uses. So it is also used by dentists to get large images of patients' teeth. So our size of teeth is very small. Size of teeth is very small, and we want to see it magnified image. We want to see a magnified images of our teeth. So, what type of concave mirror forms a magnified image? Concave mirror. So that's why a concave mirror is used to see the image of a patient's teeth by the doctors. Now, it is also used in solar furnaces to concentrate heat. Now, as I told you that concave mirror is a converging mirror. It converges light. So it can also use in furnaces to concentrate heat because it will concentrate heat at a point. It will concentrate heat at a point. So this property can be used in solar furnaces. So I hope guys these are the uses of concave mirror. So now I am ending this lecture. I hope I have been able to make you understand and we will meet in the upcoming lectures. Thank you so much. Bye bye.